At the narrowest point of the Bohai Sea, two of China's most powerful economic regions stare at each other across just over 100 kilometers of water. Every day, ships crawl slowly across the strait. Cars detour hundreds of kilometers around the coast, and billions of dollars in trade lose time to geography. But what if that stretch of sea could be crossed in under an hour, deep beneath the ocean floor, inside the longest undersea tunnel ever attempted? China's proposed Bohai Strait Tunnel is not just another infrastructure project. It is a challenge to the limits of modern engineering. Longer than the Channel Tunnel linking Britain and France, deeper than Japan's Seikon Tunnel, and far more complex than any undersea link built before. This megaproject would connect the Liaodong and Shandong Peninsulas through a high-speed rail corridor hidden beneath the seabed. If completed, it would redraw the economic map of northern China and reshape how people, goods, and industries move across the region. Yet beneath the promise lies a maze of questions. Can engineers tame the immense water pressure and seismic risks of the Bohai Sea? Is the economic payoff worth the staggering cost? And why is China willing to bet on such a colossal underwater gamble? Today, let's delve into China's Bohai Strait Megatunnel. Don't forget to click on that subscribe button and like this video, as it's the best way to support this channel. The Bohai Sea is not an open ocean, but a shallow, semi-enclosed body of water set deep within northern China. It is surrounded on three sides by some of the country's most strategically important regions. To the north lies Liaodong Province, home to the major port city of Dalian and the gateway to China's northeastern industrial heartland. To the south is Shandong Province, one of China's strongest manufacturing bases, with Yantai positioned directly across the strait. Along the western rim sits the Beijing-Tianjin corridor, the nation's political and industrial core. Despite this geographic closeness, the Bohai Sea has long functioned as a transportation barrier. Ferry crossings are slow and highly vulnerable to fog, storms, and winter ice, while rail and road traffic must detour hundreds of kilometers around the coastline. This has turned the Bohai Rim into a persistent choke point, stretching supply chains and congesting one of China's most economically vital regions. As early as the 1970s, Chinese planners began exploring the idea of a fixed link beneath the sea. At the time, however, tunneling technology was still developing globally, and China's experience was largely limited to mountain railways. The Bohai Strait's intricate geological conditions, defined by deep sediment deposits, active fault lines, and high-pressure aquifers, made such plans unfeasible at the time. By the 1990s, rapid industrial growth along the eastern seaboard and stagnation in the northeast exposed the cost of this bottleneck. Formal research intensified through the early 2000s, evolving from a basic crossing concept into a high-speed rail tunnel capable of cutting travel between Dalian and Yantai from over 8 hours to under 40 minutes. Today, the Bohai Strait Tunnel remains unbuilt, yet it endures as one of China's most strategically significant future mega corridors within its long-term infrastructure vision. The Bohai Strait Tunnel is conceived as a transformational fixed-link megaproject designed to permanently connect northern and eastern China through a direct undersea corridor. With a proposed length of approximately 120 to 130 kilometers, the tunnel would become the world's longest undersea tunnel, dramatically surpassing both the Channel Tunnel between the UK and France and Japan's Seikon Tunnel, redefining what is considered technically achievable beneath the sea. The project is primarily planned as a high-speed rail tunnel, enabling seamless passenger and freight movement across the Bohai Strait without reliance on surface transport. By eliminating ferry dependency and long overland detours, the tunnel is expected to compress regional travel times to a fraction of their current duration while improving reliability under all weather conditions. At its core, the project adopts a multi-tunnel design philosophy, integrating parallel transport tubes with a dedicated service tunnel to support ventilation, emergency response, maintenance, and operational safety over extreme distances. The alignment would extend deep beneath the seabed, requiring continuous structural integrity, advanced monitoring systems, and long-term durability planning. The Bohai Strait Tunnel represents a strategic infrastructure intervention, one intended to reshape national connectivity, elevate China's global engineering leadership, and establish a new benchmark for future subsea megaprojects worldwide. Turning this vision into reality requires a precisely staged construction strategy. The Bohai Strait Tunnel would be built over a period of 10 years or more, demanding precise coordination and sustained technological innovation. The process begins with extensive geological investigations, including seismic surveys, seabed profiling, core drilling, and computer modeling to determine the safest tunnel alignment. Once the route is confirmed, inland access tunnels would be excavated to establish the launch points for the main tunnel boring machines. Gigantic TBMs, likely custom-built with diameters exceeding 12 meters, would advance from both sides of the strait. Because of the immense length, intermediate access shafts or artificial islands have been proposed, although both options present environmental and engineering complications. These mid-sea access points would accelerate excavation and provide emergency support, but would require stable foundations in soft marine sediments. For the tunnel itself, engineers anticipate removing tens of millions of cubic meters of spoil, which must be transported, treated, and disposed of responsibly. Once excavation is complete, the focus shifts to lining installation, waterproofing, rail track laying, and electrical integration. Specialized fire suppression systems, smoke extraction networks, drainage pipelines, and high-voltage cables must be installed with precision. The tunnel is expected to function for 100 to 120 years, so redundancy and durability are paramount. The Bohai Strait Tunnel represents one of the most capital-intensive infrastructure proposals in modern history. Although the project has yet to receive final construction approval, cost estimates have steadily evolved as engineering complexity and risk assessments became clearer. Early feasibility studies placed the investment at approximately $30 to $40 billion. More recent evaluations, accounting for seismic reinforcement, ultra-long tunneling requirements, advanced safety systems, and inflation, suggest total costs could exceed $50 to $60 billion once fully scoped. Funding is expected to follow China's established megaproject model. The central government would play the leading role, supported by state-owned construction and rail enterprises, with additional contributions from Liaodong and Shandong provincial governments. Given the tunnel's national strategic value, direct fiscal support is likely to outweigh private participation, although limited public-private partnerships may emerge for auxiliary infrastructure and operations. Construction of this megaproject is expected to span a decade, reflecting the unprecedented length, depth, and geological challenges involved. If realized, the tunnel would stand as a generational investment, one designed not for immediate return, but for transforming China's northern economic geography for the century ahead. Despite its transformative promise, the Bohai Strait Tunnel faces substantial challenges that continue to fuel debate. From an engineering standpoint, the project pushes the limits of current tunneling technology. The combination of unstable seabed sediments, high water pressure, seismic fault lines, and extreme tunnel length introduces operational risks that cannot be fully eliminated, only managed. Even minor geological miscalculations could result in costly delays or safety concerns, raising questions about long-term reliability and maintenance. Economic critics argue that the tunnel's enormous upfront cost may strain public finances, particularly at a time when China is prioritizing debt control and more targeted infrastructure spending. Skeptics also question whether projected freight and passenger volumes will be sufficient to justify the investment, especially as alternative transport corridors and regional airports continue to expand. Geopolitically, the project carries strategic undertones. The Bohai Sea lies near sensitive naval installations and key industrial hubs, making the tunnel not only a civilian transport link, but also a strategic asset. While this enhances China's internal resilience, it may also attract international scrutiny, particularly regarding dual-use infrastructure and military mobility. Environmental groups further warn that construction could disrupt fragile marine ecosystems, intensifying regional tensions over sustainability. Together, these challenges ensure that the Bohai Strait Tunnel remains as controversial as it is ambitious. If realized, the Bohai Strait Tunnel would deliver benefits extending far beyond faster travel times. By physically integrating northeastern China with the nation's most dynamic coastal economies, the tunnel has the potential to reignite industrial growth, slow population decline, and rebalance regional development. Freight routes across the Bohai Rim would shorten dramatically, reducing logistics costs, strengthening supply chain resilience, and reinforcing China's domestic economic circulation. The project also signals a structural shift toward more sustainable long-distance transport. High-speed rail beneath the Bohai Sea could reduce reliance on ferries, long-haul road transport, and short-distance aviation, lowering emissions while improving safety and reliability in a region frequently disrupted by storms and seasonal ice. For passengers, journeys that once consumed an entire day would become routine, reshaping travel behavior, labor mobility, and economic interaction across northern China. Despite these far-reaching benefits, the Bohai Strait Tunnel remains a proposal rather than an approved construction project, with no final authorization or start date confirmed. Nevertheless, its momentum continues to build. Advances in deep-sea tunneling, seismic engineering, and ultra-long tunnel safety systems are steadily reducing technical barriers, while sustained policy interest keeps the project firmly on China's long-term infrastructure agenda. As with many past Chinese megaprojects, prolonged planning appears less a sign of hesitation than preparation, suggesting the tunnel is not a distant ambition, but a deferred reality awaiting alignment between vision and timing.